Hi, my name is Amy Shepherd and this is my statistical investigation. The initial question I chose to investigate was, do Year 7 students get more sleep than Year 12 students? I first visited the Census at School website to find the data that would answer my question in the random sampler section. From here, I chose the two questions that were appropriate to the investigation, which were, what year level are you in and how many hours of sleep do you usually get on a school night? I converted the data into a simplified table. The table is easy to read and shows all the relevant information needed. This is what I regularly checked in with when creating the other data displays. The double column graph is a really effective way to show the comparison side by side, and in this case it compares Year 7 students to Year 12 students' sleeping habits. This graph shows the two categorical variables clearly and is the most appropriate method for displaying the data. A dot plot is less effective than the double column graph as it has two separate graphs per categorical variable. However, it effectively shows the data in a simplistic way. As with the double column graph, it is important to make sure the axes are clearly labelled, as well as a clear title and legend. As a dot plot and double column graph are very similar as data displays, it would be preferable to choose one or the other to represent the results. A sector graph shows the data as a percentage of a whole. As a sector graph is only able to show one categorical variable, the data needs to be split into two sets, so they need to be presented together to show comparisons. This graph also needs a clear legend and title. This display doesn't show the data in the most effective way, as it is difficult to compare the two, particularly as some of the numbers are not on both sector graphs. For example, none of the Year 12 students had 10 hours sleep. Therefore, there is no section of the graph to compare to on the Year 7 one. The stem and leaf plot is a reasonably simplistic way to organise the data. It's important to be aware that the middle column represents the tens, while the outer two columns represent the units. Compared to the sector graph, the stem and leaf plot shows the data more explicitly. From the data, the mean, median and modum range need to be calculated, which is a summary statistics of the data. So, how do you calculate these? These functions are simple enough to complete using Microsoft Excel, but it's important to know how these answers are worked out manually. The mean is the average, which is calculated by adding each of the data entries together and then dividing by the number of entries. So in this investigation, I've added all the Year 7 students to answer the question, how many hours of sleep do you usually get on a school night? Which added up to 215. I then divided that by the total number of answers, or data entries, which was 25. This gave me the mean of 8.6 hours for the Year 7 students. I completed the same process for Year 12 students and got the answer of 7.2 hours. Now onto the mode. Working out the mode is as simple. Again, it can be completed on Excel, but it's basically the number that occurs most frequently within each set of data. So for Year 7s it was 9 and Year 12s it was 6 hours. Not forgetting the median and range. The median is the number right in the middle of the data when it's in order. As you can see, it's 9 hours in Year 7 and 7 hours in Year 12. Range is working out the difference between the lowest and highest number. As shown, the range for Year 7 is 10 and the range for Year 12 is 8. So, to answer the initial question, using the summary of statistics, particularly the mean, yes, Year 7 students do get more sleep than Year 12 students. On average, Year 7 students only get 8.6 hours sleep per night compared to the Year 12 students who are only getting 7.2. To summarise, the data shows that Year 7 students have more sleep than Year 12 students. It would be a good idea to collect more data and start the investigation with a larger sample size of 200 plus to be able to generalise the data. Unless the initial sample size is larger, the results can't be used without caution because there is not enough students to make up an accurate overview. So that was my statistical investigation. Thanks for listening.
Created using Powtoon.